You stand at the edge of a memory, a story told so many times, it feels like your own. You see the flash, the furious streak of light tearing through a bruised orange sky. A 6-mile-wide asteroid, a cosmic bullet traveling faster than any jet, screaming toward the Earth. This is the moment you've always pictured, the great cosmic accident, the final act in the age of dinosaurs. The dust cloud, the winter, the extinction. It's a clean, simple narrative, etched into our collective consciousness. But what if the famous asteroid was not the whole story? What if the catastrophe we imagine was actually a grand finale to a tragedy that had already begun? The asteroid didn't kill a thriving kingdom. It delivered the coup de grâce to a world already on the brink. We're about to dive into the forgotten prologue of this epic disaster, a secret buried deep in the geological record, and uncover the real story behind the most famous mass extinction in history. Imagine yourself on a warm, clear night, gazing up at the stars from a national park like Yellowstone. The air is crisp. The sky is a canvas of a million tiny lights. And you feel that familiar sense of cosmic insignificance, of being a tiny speck in a vast, ancient universe. It's a feeling that makes you wonder what else is out there, what other secrets the cosmos holds. Now, try to imagine that same feeling, but with a different kind of awe. The kind that comes from unearthing a truth that rewrites history. It's a bit like digging up an old family photograph and realizing the person you thought was a distant relative was actually a long-lost sibling. The familiar story of the asteroid impact at Chicxulub crater is true, of course. In 1991, geophysicists, thanks to the pioneering work of Walter and Luis Alvarez, pinpointed the impact site off the Yucatan Peninsula. The sheer scale of the event is almost impossible to comprehend. The force of the impact was like 100 million megaton bombs going off at once, creating a crater more than 100 miles wide. It triggered tsunamis hundreds of feet high, sent molten rock raining down for thousands of miles, and ignited a global firestorm. The immediate devastation was unimaginable, but this was only part of the story. The real killer was what happened next. The global winter caused by the endless dust and debris that blotted out the sun, plunging the world into darkness and cold for years. Most plant life died, and with it, the entire food chain collapsed. It's a solid, compelling story. So what could possibly be missing? Here's a quirky fact. That asteroid, the one that ended the dinosaurs, was likely a part of a larger family of asteroids from a cosmic pileup. Astronomers have even given this group a name, the Baptistina family, and for a long time, they believed it was the source of the Chicxulub impactor. We now know that's probably not right, as new data points to a different source. But the idea of a family of space rocks on a collision course with Earth is a pretty wild one. It's a reminder that space is not just a quiet, empty vacuum, but a shooting gallery of cosmic proportions, and we're just living in the target range. But to truly understand what really happened, we have to look much deeper into Earth's history, long before that fateful asteroid arrived. We need to go back in time, not just to the final day, but to the years leading up to it. What if the dinosaurs weren't at the peak of their power when the asteroid struck? What if they were already facing a slow, silent crisis that left them vulnerable? This isn't just about a big rock from space. It's about a complex web of environmental pressures that created a perfect storm for extinction. It's a scientific mystery that changes everything you thought you knew. Here's a mind-bending question. Do you think the dinosaurs would have survived if the Earth had been perfectly healthy when the asteroid hit? That's what we're going to explore. But first, let's dig into this mystery together. Type Explore to unlock the dinosaur's secret. What happened in that moment, and how the world was already changing, will be our next story. The story of the asteroid is the one we all know, the one that makes for great movie scenes. But the true prologue to that fiery finale isn't in space. It's right here on Earth, rumbling beneath our feet. A shadow had already fallen over the dinosaur world, not a sudden cosmic eclipse, but a slow-motion disaster, 100,000 years in the making. While the dinosaurs roamed, another colossal force was at work on the other side of the planet, in what is now modern-day India. Imagine flying over the Deccan Traps, a vast plateau of volcanic rock that covers a staggering 200,000 square miles. To put that in perspective, that's an area larger than the state of California. For millennia, this region was a pressure cooker of geological fury. The ground wasn't shaking once a day. It was perpetually trembling. Millions of tons of lava, a river of molten rock, poured out of the Earth's crust, building up layer after layer. This wasn't a sudden, explosive eruption like Vesuvius. It was a slow, persistent, and terrifying outpouring of poison. It's like a car engine slowly overheating and filling the cabin with exhaust fumes, long before it finally seizes up. These aren't just any old volcanoes. These were flood basalts, a rare and apocalyptic geological event where immense quantities of lava erupt over a short period of time. Geologically speaking, of course. We're talking about 1 million years of continuous eruptions. And with all that lava came something far more insidious. A slow but steady release of toxic gases. Carbon dioxide, sulfur dioxide, and other volatile compounds spewed into the atmosphere, changing the chemical makeup of the air and the oceans. It was like the planet was holding its breath, slowly poisoning itself. The initial effect was a massive greenhouse effect. All that carbon dioxide trapped heat, raising global temperatures by several degrees. The oceans warmed, causing sea levels to rise and changing the marine ecosystems that served as the base of the global food chain. Then came the twist. The sulfur dioxide mixed with water vapor in the atmosphere, forming sulfuric acid aerosols. These tiny particles acted like a mirror, reflecting sunlight back into space. This caused a cooling effect, plunging the Earth into a volcanic winter before the asteroid even showed up. It's a classic scientific joke. What's the difference between a geologist and a paleontologist? The geologist asks, what caused the eruption? The paleontologist asks, did it wipe out all the dinosaurs, or just most of them? This wasn't a single event. It was a 1-2 punch delivered by the Earth itself. The dinosaurs didn't just live through a catastrophe, they lived through a pre-catastrophe. They were already weakened, their populations stressed, their food chains disrupted. They were like a boxer who's been taking hits for a dozen rounds before the final knockout punch. The asteroid was the final blow. But the Deccan Traps eruptions had already softened them up, making the extinction inevitable. In a sense, the dinosaurs were already dying from 1,000 cuts before they faced the final, fatal wound. This idea of a dual disaster model, volcanoes followed by an asteroid, is a relatively new and powerful theory. It helps explain why the extinction was so complete and so sudden. It wasn't just the sheer force of a cosmic impact that did them in. It was the fact that the Earth's ecosystems had already been made incredibly fragile. The asteroid didn't just break the camel's back. It broke a back that was already bent under an impossible load. Here's a question for you. Do you think the volcanoes or the asteroid were the primary reason for the extinction? The story is far from over, but the stage is now set for the final, brutal act. Volcanoes or asteroid? You decide. Type volcano, or asteroid in the comments to choose. And then the moment arrived. After 100,000 years of slow geological decay, the final blow came from the sky. You're no longer a distant observer. You are there, standing on a beach in what will one day be Mexico, watching the sky. The air is thick with the scent of pine and a faint, acrid smell from the distant volcanic plumes. You look up and see a sight that no human eye has ever witnessed, and thankfully, never will. A pinprick of light grows with impossible speed, a star falling from the sky, not with a gentle arc, but a determined, terrifying plunge. It's not silent. A high-pitched shriek, a whistle of atmospheric friction, builds to a thunderous roar. This isn't the calm, cool vacuum of space you see in Star Wars. This is a fiery, superheated collision with a thick atmosphere. The air around the asteroid is so hot it glows with a blinding, white-hot plasma. It's like a meteor shower, but one that lasts for a full minute, getting brighter and bigger until it fills half the sky. You can feel the heat on your face, a searing warmth that quickly becomes unbearable. This isn't just a rock. It's a celestial weapon of mass destruction. For a few heart-stopping moments, the world holds its breath. The asteroid, a 6-mile-wide behemoth, is about to make its mark on a planet already in decline. The impact zone is the Yucatan Peninsula, a shallow sea at the time. The water is instantly vaporized, leaving a superheated chasm in its place. The ground trembles, not in a gentle earthquake, but with a shock wave that travels through the bedrock at hypersonic speeds. The impact is so violent, it sends a plume of vaporized rock and dirt hurtling into space, a cosmic geyser that rises far above the atmosphere. It's a literal punch to the planet's face. But the worst part isn't the initial impact. It's the aftermath. The energy released is incomprehensible, equal to 100 million times the power of the atomic bomb dropped on Hiroshima. This wasn't just a blast. It was an instantaneous reshaping of the Earth's surface. A massive tsunami, hundreds of feet high, radiates outwards, scouring the coastlines of North America. Fires ignite thousands of miles away, started by the intense heat of the impact. Then, the molten rock that was thrown into the sky begins to fall back down. It's like a reverse meteor shower, with superheated droplets of glass and rock, called tektites, raining down on the planet. These tiny particles, glowing red-hot, ignite the world's forests, turning the Earth into a fiery furnace. It's a scene of biblical proportions, a global inferno that burns for days. The dinosaurs, the great titans of the Mesozoic, had no idea what was happening. They were already weak from the volcanic winter. They were already living in a world of stressed ecosystems. And then, in a single, terrifying instant, the sky caught fire. Here's a historical fact for you. The asteroid impact was so powerful, it may have triggered further volcanic activity around the world, particularly in the Deccan Traps, which might have been a final, explosive gasp of a dying geological system. It's a mind-bending idea that the very force that finished the job also reignited the original catastrophe. So, how do you describe this moment? A single cataclysmic event that rewrote the planet's fate. A punch so hard it fundamentally changed the course of life on Earth. But how can we put that into words? What does the impact really look like? How would you describe the collision in a single word? Type one word to describe the impact. The fires are over. The explosions have stopped. The ground is still, and a haunting silence falls over the scarred planet. You're no longer standing on that beach. You're now somewhere inland, perhaps in a place that will one day become the American West. The landscape is a charred, blackened wasteland. But the real change is in the sky. The sun, our familiar star, has vanished. Not literally, of course, but it might as well have. The impact and the subsequent global firestorm threw trillions of tons of soot and dust into the atmosphere. This wasn't just a simple cloud. It was a permanent planetary twilight. The dust acted like a massive, global blanket, blocking out almost all sunlight. The Earth was plunged into a sudden, deep darkness that lasted for years. You can't see the stars, but you can't see the sun either. It's an endless, eerie twilight, a permanent, overcast day. It's a world without warmth, a world without photosynthesis. This is the true, hidden horror of the extinction event. The dinosaurs didn't just burn up or get swept away by tsunamis. They starved to death in the cold and the dark. The darkness was a death sentence for most plant life. Without sunlight, plants couldn't perform photosynthesis, and they died off almost completely. It's a simple, brutal logic. No plants, no herbivores. No herbivores, no carnivores. The entire food chain, which had been weakened by the volcanic eruptions, collapsed like a house of cards. The dinosaurs, the apex predators, and the massive plant eaters were simply too big and too specialized to survive on the meager scraps left behind. The cold was just as devastating. Without the sun's warmth, global temperatures plummeted. We're talking about a sudden, violent drop that turned what was a warm, tropical planet into a frozen wasteland. It was a global winter, an ice age that came on not over millennia, but over a matter of weeks and months. It's a sobering thought. The very thing that makes our planet habitable, a comfortable distance from the sun, was temporarily nullified by a single cosmic event. It's a reminder of how fragile our planetary systems truly are, and how quickly everything we take for granted can be taken away. This is where you feel a deep, emotional connection to the past. You've probably experienced a power outage or a long, dark winter day. But imagine that, for years. No warm sun on your face, no green leaves on the trees. The only light comes from the moon or the faint glow of distant fires. What would you miss the most? Maybe the feeling of a warm, summer day at a national park? Or the sight of a vibrant green forest? The dinosaurs lived in that kind of world, a world where the most fundamental elements of life, light and warmth, were taken away. Here's a quirky fact. Some paleontologists believe that the animals that survived this global winter were the ones that could either burrow underground, like small mammals and lizards, or those that lived in water, where the temperature was more stable, like fish and crocodiles. They didn't survive because they were the strongest or the smartest. They survived because their very existence made them immune to the darkness and the cold. So, as you explore a new Earth shrouded in darkness and cold, you have to ask yourself, how did life adapt to this sudden, global night? It's a testament to the resilience of life that anything survived at all. But what would you miss most if the sun vanished? Type what you would miss most about the sun. The world has changed. The giants are gone. The colossal, awe-inspiring dinosaurs that ruled the land for 160 million years are now silent, their massive skeletons buried under layers of ash and sediment. But not everything perished. A new, strange world has dawned, a world of permanent shadows and muted colors. And in this new world, life found a way. The survivors weren't the titans, the long-necked sauropods, or the fierce Tyrannosaurus rex. They were the small, the nimble, and the adaptable. Imagine a world where the biggest thing you see is no larger than a house cat. The survivors were creatures that could burrow underground, creatures that could eat almost anything, and creatures that could endure a deep and sudden cold. These were the true inheritors of the earth: small mammals, crocodiles and alligators, turtles, and even some birds, which we now know are the direct descendants of the dinosaurs themselves. Think about a crocodile, a living fossil, if ever there was one. These ancient reptiles were a master class in survival. They could slow their metabolism, go for long periods without food, and live in the relative thermal stability of water. When the world above ground was burning and freezing, they were safe in the rivers and swamps, waiting for the storm to pass. They didn't need to adapt. They were already perfectly suited for catastrophe. It's a bit like a prepper who has a fully stocked bunker when the apocalypse hits. They weren't lucky. They were just prepared. The small mammals of the time were even more remarkable. They were the underdogs of the dinosaur age, scurrying around in the shadows, living in burrows, and scavenging for food. When the asteroid struck and the skies went dark, they had an immediate advantage. They didn't need the sun to warm their bodies. They were endothermic. They could also survive on a wide range of food, from insects to seeds to small lizards, giving them a flexibility that the specialized herbivores and carnivores of the dinosaur world lacked. These furry, rat-like creatures were not just survivors. They were the progenitors of an entirely new era of life. Every mammal on Earth today, from the blue whale to you and me, can trace its lineage back to these small, resilient creatures that weathered the storm. Here's a smart, science-based joke for you. What did the tiny mammals say after the asteroid hit? I guess the dinosaurs couldn't handle the heat. It's a reminder that sometimes being small and inconspicuous is the ultimate superpower. This is the great paradox of the Extinction event. It was a moment of unimaginable destruction, but it was also a moment of creation. The death of the dinosaurs made room for an entirely new kind of life to flourish. Without the dinosaurs, mammals would have remained a footnote in history. But with the competition gone, they were free to evolve and diversify, eventually giving rise to the incredible variety of life we see today. The legacy of the dinosaurs, in a strange and beautiful way, is a world filled with mammals. So, as you look at the creatures that weathered the storm and the improbable lineage they created, you have to ask, how did life find a way to endure? It's a testament to the fact that even in the face of total devastation, a seed of new life can still take root. Can you name a species that could survive any catastrophe? Type your answer in the comments. The dust has settled. The air has cleared. The planet is no longer shrouded in permanent twilight. But the world that emerges is unrecognizable. The global inferno and the subsequent deep freeze left behind a scarred, barren landscape. The forests are gone, replaced by blackened stumps and ash. The once thriving swamps are now desolate, stagnant pools. It's a somber, muted world, a planet healing from a deep and terrible wound. But here, in this quiet, wounded world, is where the most hopeful part of our story begins. The slow, triumphant rebirth of life. The first signs of recovery are small and tenacious. Imagine yourself walking across a landscape that looks more like a desert on Mars than the verdant Earth you know. But then, you see it. A tiny green shoot pushing its way up through the dark, nutrient-rich volcanic ash. These are the pioneer species, the first plants to reclaim the scorched earth. Ferns and other hardy, low-lying plants that can reproduce quickly and thrive in a world with little competition are the heroes of this new age. They begin the slow, meticulous processes of terraforming the planet, rebuilding the soil, and creating the foundation for a new ecosystem. This is the beauty of life's resilience. It doesn't matter how much devastation you throw at it. If even a single seed survives, life finds a way to return. It's a powerful lesson, a reminder that destruction is often the prelude to creation. This is a bit like a forest fire in Yellowstone National Park. While the fire is a tragedy, it also clears out old, dead wood and makes way for new growth, allowing a new, healthier forest to emerge. The dinosaur extinction was a cosmic forest fire, and the new world that emerged was a completely new forest. As the plant life returned, so did the animal life. The small mammals and birds that survived the catastrophe began to venture out of their burrows and hiding places. They had an open field to play on. With the giant dinosaurs gone, there was a void at the top of the food chain, a massive ecological niche just waiting to be filled. The mammals, once the meek underdogs, began to evolve rapidly, growing larger and more diverse. They filled every available role, from herbivores to carnivores, from tree dwellers to swimmers. It's a perfect example of adaptive radiation, a quirky fact of evolution where a group of organisms rapidly diversifies to fill new ecological spaces. It's a reminder that sometimes the biggest opportunity comes from the greatest disaster. This new world, the one that emerged from the ashes, would one day become our world. The dawn of the Cenozoic era, the age of mammals, was directly made possible by the death of the dinosaurs. The same events that killed the giants paved the way for the rise of a new kind of life, a lineage that would eventually lead to us. The scars of the extinction event are still visible in the geological record, in a thin layer of iridium-rich clay that marks the boundary between the Mesozoic and Cenozoic eras. It's a global monument to a moment of unimaginable destruction, but also to a new beginning. So, as you witness the slow, triumphant rebirth of life and the dawn of a new era, what does a planet's recovery look like? It looks like a story of resilience, of tenacious plant life, and of small, adaptable creatures seizing their moment. Which species that survived the dinosaur era do you find most interesting? Type your choice in the comments to let us know. Just when you think you have the story straight, a 1-2 punch from volcanoes and a meteorite, scientists uncover a strange and unsettling twist. The geological record, which serves as a planetary diary, contains clues that suggest something more than just a series of natural disasters was at play. We're talking about a scientific mystery that changes the whole game. A detail that makes you wonder if our understanding of Earth's greatest catastrophe is fundamentally flawed. Imagine a crime scene where the evidence doesn't quite add up. You have the smoking gun, the asteroid, and you have a motive, the volcanoes. But then you find a strange, third piece of evidence that suggests another culprit altogether. That's what's happening in the minds of some paleontologists and geochemists. They're finding subtle but persistent signs in the rocks from the end of the Cretaceous period that point to an unnatural force at work. Specifically, scientists are uncovering evidence of a widespread, rapid global acidification of the oceans. This isn't just a slow change, it's a sudden drop in pH that would have devastated marine life, particularly organisms like plankton and coral that rely on calcium carbonate to build their shells and skeletons. The famous Chicxulub impact could certainly cause some ocean acidification, but the scale and timing of the evidence suggest that something else was already weakening the marine food chain long before the asteroid arrived. The theory is that the massive volcanic eruptions at the Deccan Traps released enormous amounts of sulfur dioxide and other gases, which mixed with rainwater to form acid rain. This rain then fell into the oceans, slowly but surely turning them more acidic. But here's the unsettling part. Some researchers argue that the effects seen in the fossil record are too severe to be explained by volcanoes alone, and they don't perfectly match the timing of the Chicxulub impact. They are pointing to a potential third, more sinister factor, a global epidemic or disease that swept through the dinosaur population, already weakened by the changing climate. This is, of course, a highly speculative and controversial theory, but the clues are intriguing. Dinosaurs were a massive, interconnected population, and a highly contagious, fast-acting disease could have spread like wildfire through their ranks. Here's a quirky fact. Some of the strange stunted growth seen in dinosaur fossils from the late Cretaceous period could be interpreted as signs of a population under severe environmental stress or disease. This isn't about throwing out the asteroid or the volcanoes. It's about adding another layer to the story, a layer of complexity that makes the extinction even more profound. The dinosaurs might have been facing a perfect storm of environmental pressures, but what if a hidden force, a pandemic on a planetary scale, was already a ticking time bomb? This leads to an open-ended question that makes you rethink everything you know. Was there a hidden force at work? Was the extinction driven by climate, disease, or something else entirely? It's a scientific whodunit with clues buried in the rocks themselves. Let's make a guess and see what you think. Was the real mystery climate or disease? Type climate or disease to guess the hidden force. The question of what truly killed the dinosaurs is not just a historical puzzle. It's a cosmic one. It's a mystery that leads us directly to one of the most profound questions in all of science. The Fermi paradox. This is the great silence. The unsettling observation that with billions of stars and potentially billions of habitable planets in our galaxy, we have yet to find any evidence of intelligent extraterrestrial life. Where is everybody? The story of the dinosaurs gives us a chillingly plausible answer. What if the universe isn't full of ancient, wise civilizations, but of worlds that are routinely reset by cosmic catastrophes? The dinosaurs' extinction wasn't a fluke. It was a cosmic accident waiting to happen, a statistical inevitability in a universe full of rogue asteroids and geological time bombs. It makes you wonder, what if the natural lifespan of a planet with intelligent life is just long enough to develop space travel, but not long enough to survive the next cosmic bullet? It's a bit like a cosmic game of Russian roulette, and Earth just happened to get lucky and survive a few rounds. Our story, the story of humanity, only became possible because of this cosmic reset button. If the asteroid had missed, the dinosaurs would likely still be here, and we wouldn't. The rise of mammals, and eventually us, was a direct consequence of a planetary catastrophe. The fact that we exist at all is a cosmic fluke, a product of a mass extinction event. This idea connects our deep past to our cosmic future in a very direct way. The same forces that shaped our past could also shape the universe's future, and they might be the reason for the great silence. Here's a smart, science-based joke. Why did the dinosaur cross the road? To prove it wasn't an asteroid that killed it. It's a silly joke, but it gets at the heart of the matter. We're obsessed with this extinction event because we know that it could happen to us. We're constantly scanning the skies for near-Earth objects, building telescopes like the one at the Pan-STARRS Observatory in Hawaii, and planning missions to deflect potential threats. We are, in a sense, trying to prevent our own Chicxulub moment. We are the first species in Earth's history to be aware of these cosmic dangers, and we're the only ones who can do something about it. So, as you ponder the great question of whether we are alone in the universe, consider this. Maybe the reason we don't hear from anyone is because every time a civilization gets to a certain point, a cosmic event wipes the slate clean, resetting the clock for the next species. It's a sobering thought, but also a powerful one. It places our own existence in a much larger, more cosmic context. We are a part of a much bigger story, one that spans millions of years and stretches across the cosmos. It's a story of survival, of resilience, and of a very fragile future. The Fermi paradox is not just a question about aliens. It's a question about our own place in the universe. Do you think there are aliens out there? Type aliens or no aliens in the comments. Our story of the dinosaurs and their demise isn't just about Earth's ancient past. It's a story with an echo in the stars. The same forces that shaped our history are playing out across the cosmos. And if we want to understand our future, we have to look up. We are, in a very real sense, a product of a cosmic drama. And the clues to our own destiny might be found in a distant star, a million light years away. Imagine a star system not unlike our own, a star with a planetary system and a fragile nascent biosphere. Now, imagine a cosmic event, a supernova, in a nearby star system. This isn't just a pretty light show. It's a cataclysm of unimaginable power. A supernova explosion can unleash a torrent of high-energy particles and radiation, including cosmic rays. If a supernova were to occur too close to our solar system, it could strip our planet's atmosphere, fry our electronics, and trigger mass extinctions. It's a chilling thought. The same forces of creation that forge the elements of life can also be its ultimate undoing. This is the great connection between the dinosaur extinction and our cosmic future. The asteroid that hit Earth was a consequence of the chaotic, violent nature of our solar system. The solar system is not a pristine, quiet place. It's a shooting gallery of comets, asteroids, and other rogue bodies. This is a simple, quirky fact of orbital mechanics. The Earth is in a constant, low-level game of dodgeball with the rest of the cosmos. The Chicxulub impact was just a moment when we failed to dodge. In a similar vein, the universe itself is full of cosmic threats, from supernovae to gamma-ray bursts, which could reshape a planet's destiny in an instant. The story of the dinosaurs isn't just a cautionary tale, it's a cosmic roadmap. It shows us what happens when a planetary system is vulnerable to outside forces. It tells us that our existence is fragile, and our future is not guaranteed. This is a bit like reading a history book that contains a chapter on a civilization that was wiped out by a tidal wave. You can look at that story and see the past, but you can also see the potential for your own future. That's what we're doing when we look at the dinosaur extinction. We're not just looking back in time, we're looking forward. This leads to a big question. Could our ancient past hold the key to our cosmic future? By studying the extinction event, we are not just learning about the fate of the dinosaurs. We are learning about the fate of any civilization on any planet. We are learning about the natural cycles of destruction and creation that govern the universe. In a very real sense, humanity's story is tied to a distant star, and its violent demise could be our next great challenge. Which star do you want to explore? Type a star name in the comments to explore it. Our journey to the end of the dinosaurs has taken us from the fiery impact of an asteroid to the slow burn of volcanoes and the chilling mystery of a potential disease. We've looked at the past, pondered the present, and even glanced at our cosmic future. But now we arrive at the final, stunning revelation. The story of what truly killed the dinosaurs is not just about a series of events from 66 million years ago. It's about a truth that still lives on today. A connection between their world and ours that you can see with your own eyes. The final unseen connection is this: the dinosaur extinction was not just an end, it was a cosmic filter. It was an event of such overwhelming scale that it fundamentally reset the course of life on Earth, paving the way for our existence. The dinosaurs had their chance, their long, magnificent run, and their world ended because a series of vulnerabilities, from the volcanoes to the asteroid, all aligned perfectly. Our story, the story of humanity, only began because that filter was so effective. We are here not because we are the ultimate evolutionary masterpiece, but because we are the improbable survivors of a cosmic lottery. And here's the mind-bending twist. The same forces that killed the dinosaurs are still at work today, and they are still shaping our world. The geological pressures that caused the Deccan Traps eruptions are still bubbling beneath the surface of our planet. Asteroids and comets are still hurtling through space, and our planet is still in their path. The same cosmic vulnerabilities that doomed the dinosaurs are the same ones that we, as a species, must now learn to overcome. The story of the dinosaurs is our story in reverse. Their extinction is a mirror, showing us a potential future we are actively working to prevent. This is the deeper meaning of the Great Extinction. It's a humbling reminder that we are not the masters of this planet. We are a part of its complex, chaotic, and often violent history. Our fate is tied not just to our own actions, but to the natural rhythms of the Earth and the unpredictable violence of the cosmos. The most important lesson of the dinosaur extinction is not that a giant rock killed them. It's that life is fragile, and the universe doesn't care about our plans. We are here because of a moment of unimaginable destruction, and our task is to ensure that a similar moment doesn't end our story too. So, as you reflect on this journey, on the death of a kingdom and the birth of a new world, what do you feel? Awe? Fear? Hope? This is the power of science. It allows us to feel a deep connection to events that happened millions of years before we were born. It allows us to feel the weight of history and the fragility of our own existence. Our story is not just about the past. It's about a present truth. Uncover the final stunning revelation about what truly killed the dinosaurs. Like and share to uncover more cosmic secrets. If you liked this journey, make sure to like, subscribe, and share with your friends. Join us next time as we ask another mind-bending question. Are we alone in the cosmos? Or is the great silence a sign that someone is out there?